which is more effective? Ice at 0 degree temperature. Do that check. Check it once. Hmm? Is it in your copy?
Yes, sir.
Yes. Which is more effective in cooling? Ice or water at 0 degree temperature? Okay. Do we have done this one?
Yes,
Yes, sir.
sir.
Okay. And this one also? All the graphs?
Yes, sir.
Okay. Just a minute. Let me start with the question. Okay, tell me the answer of this question.
Sir, we did this.
Yeah, we did this, but tell me the answer again. What is the answer for this question?
Sir, it's C. Low temperature and high pressure.
Low temperature and high pressure. Low temperature and high pressure. Yes, we can convert it. The natural gas can be converted into, for example, you have a gas in a chamber. Okay, and this is the gaseous particle. Okay, trapped inside it, they are gas particles. And if you want to liquefy it, means you want to bring, for liquefaction, you have to bring these particles closer to each other. So you have to apply this piston, you have to apply the pressure over it. And when you apply the pressure over it, what is going to happen? This piston will come closer, nearer to the bottom. And when it come nearer to the bottom, so it will be closer. And all the particles here, okay, will be coming and they will convert it into gas from liquid. So it is gas. From gas, it will get converted into liquids. Is it okay? Yes or
Yes,
no?
sir.
Okay. Next. Okay. Tell me what is the answer for this question? Do it and tell me the answer for this question.
So option D.
Okay. Option D.
Sir, we also did this.
Yeah, we did this one. We know. I know this one that you have done this one, but let me check your memory. Okay. So just a minute.
It's D, sir.
It's D. Okay. Let me have more questions. Just give me a second. Some more questions. Just a minute. Okay. Tell me this. Tell me this question. Fusion is fusion is
Solid to liquid.
conversion of
Solid to liquid.
Solid to liquid. Very good. Very good. Just, what is the answer for this question? Uh, yes, fusion is change of liquid state from solid to,
Liquid.
when solid changes to liquid, it will take latent heat of fusion. Okay, so this is fusion. Okay, next. Tell me the answer for this question. It's okay, Saad.
So it's C.
Sir, C. C.
So C.
C. Okay, it's C. What is it? In the given experiment, the crystal of potassium permanganate is added to the water. Okay. Further dilution is done as shown in the figure. Okay. What conclusion did you draw on? Will you draw? What conclusion will you draw from the experiment? The particles are very small in size, very large in size. No, particles are not very large in size. Size of the particle does not affect the solution. Yes, it affects the solution. In the particles are very, very small and keep on dividing to form smaller particle. Yes, this is the correct option. Very good. Proud of you. I'm very, very much proud of you. Okay, you are just learning and participating in the class. It means that you are able to answer. It means that your concept is clear in each and everything that we are teaching you. It is getting into your mind. Okay. Okay, then tell me, what is the answer for this question?
So B.
B. Others? Other
Sir,
students?
B.
It is B.
B. Sir,
Okay.
B.
Okay, B. Yeah, it is B. It is correct that it is B. Next question. Match the following. Okay, tell me. The unit of pressure is?
So Pascal.
Sir,
It is
Pascal.
very good. The unit of temperature is?
Kelvin.
Kelvin.
Very good. It is Kelvin. Density?
Cubic meter.
Cubic meter.
Cubic meter.
Per kilogram per centimeter cube. It is E. Then
Okay.
is kilogram per centimeter cube. Mass?
Kilogram.
It is kilogram.
Kilogram.
Volume?
Cubic
Cubic
meter.
meter. Cubic
Cubic.
meter.
It is cubic meter. It is cubic meter. Okay. Okay. So note it down in your copy. Do it. Do it. Everybody note it down. Note it down in your copy. When you're done, please let me know.
Answer.
Done, everybody?
Yes, sir.
Yes, sir.
So today we shall be studying the another topic. We have studied the latent heat. We have done the questions over the latent heat. We shall start the topic evaporation. Okay, evaporation. What is evaporation? Can anybody in the class tell me what is evaporation?
The conversion of liquid into gas is known as evaporation.
Convergence of liquid into gas without below its boiling point. Okay, below its boiling point. So if I'm saying here, what is Kelvin? Sorry, what is evaporation? Sorry, I'm sorry. What is evaporation? What is evaporation? Evaporation. So what is evaporation? The phenomena of conversion. The phenomena of conversion of solid, sorry, liquid into gas. Liquid into gas below its boiling point. Below its boiling point. Boiling temperature or boiling point is called evaporation. Note it down, dear students, please.
Sir, done.
Yes,
Okay,
sir.
Sir, done.
very good. Next, if I ask you the question, what is the difference between boiling and evaporation? What is the difference between boiling and evaporation? Can anybody in the class tell me what is the difference between boiling and evaporation? Okay, let me explain you that boiling is done at a particular temperature. Okay, boiling is done at a particular temperature. Okay, and it's like, for example, boiling for hot water is done at a particular temperature, that is 100-degree temperature. Okay, so we'll simply say here that boiling and evaporation can be done at all temperatures below the boiling point, like at 40 degree also. Sometimes the water, if it get splitted on the floor, okay, then it will get evaporated. Do you think that the room temperature is 100 degree? No, the room temperature cannot be 100 degree, because you can check the environment. We cannot even live at 100-degree temperature. Okay, just a minute, I'm just coming back. Okay, dear students. So the phenomena, simple, we can say that boiling, if I talk about the boiling and evaporation, then boiling is a bulk phenomena and evaporation is a surface phenomena. Okay, evaporation is a surface phenomena. Okay, surface phenomena. Boiling is a bulk phenomena. Means when you boil something, the whole water particles start getting kinetic energy and they start moving. Okay, but in the evaporation, what is going to happen? The surface particles only. This is a surface particle. They leave the surface. Only the surface particle leave the surface. The whole mixture or whole water is not going to be have, means all the particles are not moving with greater kinetic energy. But when you boil water, let's suppose you start boiling water, then not only the surface particle, the other particles also uh, boils, they also have the kinetic energy, they also move here and there. So it is a bulk phenomena. Okay, so we will say that boiling is a bulk phenomena while evaporation is a surface phenomena. Okay, boiling is a bulk phenomenon. Okay, while evaporation is surface phenomena. Surface. Okay, Got it? Boiling is done at boiling temperature, boiling point. It is it it is done at boiling point or at boiling temperature, boiling temperature, boiling point. Okay. It can be done. It can be done. It can be done below boiling point. Boiling below boiling temperature. Below boiling point. Okay. Below boiling point. Got it?
Yes, sir.
Yes,
Is there
sir.
any
Yes, sir.
understood?
Hmm.
So in the surface, okay, in this surface, we can say that in the boiling, you can simply say that. Let me explain you with the help of a video lecture. If there is a video lecture, let me show you this one. Just a minute. Difference between boiling and
boiling at what?
is it visible to you? Screen is visible to you or not?
Yes, sir.
Is it visible? Okay,
Yes, sir.
you can check it.
Of evaporation, but evaporation is not necessarily boiling. Now let's take a look at what this means. We have all seen a pot of boiling water. We also know that water will evaporate and dry on its own if left out long enough. But what distinguishes boiling from basic evaporation? Boiling occurs when a liquid reaches a critical temperature where the vapor pressure is equal to or greater than the ambient pressure. This means that as water boils,
What do you mean by ambient pressure? Ambient pressure means the outer atmospheric pressure. Okay, means when the boiling is done, when uh the temperature, or we can say that the pressure, the pressure of the particles is equal, means of the liquid is equal to the atmospheric pressure. Okay, and it is done. For this, we have to achieve a particular temperature. For example, at 100-degree temperature, or we can say that at 100-degree temperature, the vapor that is exerting the pressure over the atmosphere become equal. Okay, they become equal. You understood? So at this temperature, they become equal.
pushes the air out of the way and the gas directly over the water is pure vapor. With evaporation below the boiling point, the vapor pressure is less than the ambient pressure. This means that the gas over the surface of water is partially water vapor and air. This vapor can distribute into the air via diffusion, or if it is blown away by a draft of air. So as you can see, boiling is evaporation, but evaporation is not necessarily boiling. However, even though evaporation can occur in different ways, the energy required to turn water into vapor is the same, about 2,300,000 joules per kilogram of water. In the case of boiling, the heat comes exclusively from the heat source, in this case a flame. In the case of evaporation, however, there can be a heat source, or the heat can be pulled from the environment. This is how we are cooled by sweat, as our bodies supply the heat to evaporate the water. Thanks for watching.
Okay, so what do you understand here?
Boiling is a form of
Okay, what do you understand here is that simple, very simple, that boiling is done at a particular temperature. First of all, let me explain you what is the boiling point. What is boiling temperature? Okay, let me explain you what is boiling. Boiling is, we can say that, what is boiling point? First of all, let me explain you what is boiling point. For example, For example, you have a water, okay? You have in a china dish, or you can have a simple a tumbler, okay, in which you are having some water, okay? You are having some water, okay? And you have closed this lid, okay? You have a closed container here, and you have placed a closed container here like this way. Okay, this is a closed container, and then you have applied a pressure gauge here, pressure that measure the pressure. We called it pressure machine or pressure measuring units we are having here. Okay, and you start heating this. You start heating this appliance. Okay, initially the water will not. Initially the water will not evaporate, but when you keep on heating, then the whole particles, the bulk particles, all the particles will get the kinetic energy, same kinetic energy, and they will start creating a pressure over it. Okay, they will create. You know that at this pressure here, initially there is an atmospheric pressure. There is an atmospheric pressure which is exerting over this atmosphere because of the air. It is exerting the pressure. Okay, and this liquid is also exerting the pressure. If the atmospheric pressure is less than the liquid pressure, so it will remain in the liquid state. It will not leave the surface of the water. If the atmospheric pressure, which is also called ambient pressure, atmospheric pressure, if the atmospheric pressure is greater than the vapor pressure of liquid, okay, because this is also exerting, but it is greater, and atmospheric pressure is more. The vapors are not exerting that pressure, so it will remain in the liquid state. Okay, because it is heavier, or we can say the atmospheric pressure is more, so they are exerting more pressure over it, and they will not allow the water particle to get convert into the vapor state. But when atmospheric pressure, when you keep on heating this one, the particles start getting the kinetic energy. So at this temperature, we'll say that atmospheric pressure, and you keep on adding heat to it, then it will become equals to vapor pressure. Okay, and then when atmospheric pressure become equal to vapor pressure of liquid, okay, then the water particles can leave the surface, and they can, because the pressure is equal, the force they are exerting, force it is equal, so they both can move from one place to, the particles here can move from. So at this atmospheric pressure, the gas, or we can say that the liquid will convert into gas. The liquid will convert into gas. It will get converted into gas. Is that clear? Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Now you need to understood here one thing, that if the atmospheric pressure is greater than the vapor pressure, it will remain in the liquid state. But if the atmospheric pressure is equal to the vapor pressure, then the liquid can leave the surface, and they can convert it to gas. Okay, so this is called boiling. Okay, and but you know that here we are just exerting this pressure in boiling by heating. In boiling, this is done, means this atmospheric pressure is become equal to the vapor pressure, and this is done by heating. But what happens in the evaporation? We need not to have the temperature. Okay, but if there is no temperature requirement, but since if I'm saying that, suppose this is the this is the water in this one. Okay, and you know that if we are just blowing the air is coming from here, the air is blowing, okay, and then it is moving like this way. So what would happen, this air will actually comes in the contact with the above surface particle, and then will strike to the upper surface particle, and will take the particles of the upper surface along with it. Okay, they will take the particles of the what? Tell me. They will take the particles of the
Upper surface.
upper
Upper surface.
along with it. Okay, along with it, and this is known as evaporation. So here this energy of removing this water particles from the top surface is partially done by Some is done by heating, because you know that there is some temperature will be required. For example, 40 degree, 50 degree. Some is done by heating, some is done by air. Okay, got it? Some is done by heating and some is done by air. Okay, you understood?
Yes, sir.
Yes, sir.
But the total energy that is being required in the boiling, for example, if you want to remove if you want to convert 1 kg of water into vapor state, whether you did it by the boiling or whether you did it by the evaporation, the sum of the all the energies will be equal.
Yes, sir.
Okay, the sum of the energies will be equal. It does not mean if you did this process by evaporation, it will take less energy. No, the air is also giving its energy to it. Okay, so we will add this all energies that are taking place in removing the water from the top surface and removing the and converting the whole water into vapor. It is same. Either you boil the water 100 degree by giving it 100-degree temperature, or either you evaporate the water by using air, temperature, partial air. The energy will be same. The same energy will be required. Okay,
Yes,
got
sir.
it?
Yes, sir.
Total energy of convergence of solid into liquid, the sum of all the energies of convergence into liquid into gas, either by done by boiling or either done by evaporation, is same. Got it? So
Yes, sir.
note it down. Sum of all the energies of conversion of particular liquids, particular amount of liquid, either by evaporation or boiling, will be same. Done? Yes or no? Done?
No, sir.
No, sir.
Okay. Now, what are the factors that are responsible for the evaporation? If you want to evaporate something, okay, in the previous class, we have learned that boiling can be done at lower pressure, lower temperature also. Do we have learned this one? That boiling can be done at lower pressure. How can we boil the water at lower pressure? Or
Sir.
can we boil the water at, if the boiling temperature of water is 100 degrees Celsius, can we boil the water at 50 degrees Celsius? Is
Yes,
it?
sir.
Yes, we can boil the water
Yes, sir.
by decreasing the atmospheric pressure over it. So for example, if you are having this chamber, okay, and you are having some water over it and you want to boil it, if you are boiling in open air, then it will be the atmospheric pressure that is affecting it, or don't want to convert it into liquid state. Okay, sorry, gaseous state. So it will done, or what we need to do here is that we need to cover this one, okay, and we just keep this one in a closed chamber, okay, and remove and vacuum this one. Okay, this is a vacuum pump, and when you vacuum it, then what is going to happen? Simple, this atmospheric pressure will be removed, because if you remove the air, the atmospheric pressure will be removed. And now it will boil. It can, because there is no resistance force that is opposing it to boil, but that is opposing it to convert into the liquid state. Sorry, solid state. Sorry, gaseous state. So we will simply say here that it can easily boil. You understood? At
Yes.
lower. So if you
Yes, sir.
reduce the pressure, atmospheric pressure, the boiling temperature will be reduced, and the boiling temperature can be attained at lower temperature. Okay,
Yes, sir.
got it?
Yes, sir.
Yes, sir.
So factor, next topic is factor affecting the rate of evaporation. Factor affecting the rate of evaporation. Okay, tell me. What are the factors that affect the rate of evaporation?
So atmospheric pressure.
Yeah, we can say atmospheric pressure also. If you reduce the atmospheric pressure, so you can say atmospheric pressure is one of that one. Okay.
So temperature.
Yeah, it will be temperature. Other
So
other.
Air.
surface area occupied by the liquid.
Yeah, very good.
Pressure.
Very good. Okay. So Asad, are you there?
Yes, sir.
Okay. Are you getting? So for example, if you are
Yes,
having
sir.
a clothes, okay, if you wash your, let's suppose your mother wash her dupatta, okay, and she wants to get it dry, okay. So what she need to do? Will she keep it folded, okay, and keep it in some place, okay, which is cold, colder? Will it get if means dry, or if she uh open it and increase its surface area, the whole surface area, and then place it on the rope, will it dry faster? In which case it is going to dry faster.
So could you repeat?
I'm saying, for
Sir,
example,
could you
you
repeat?
have your mother wash the dupatta, which is having this surface area, okay? If she keep it in the folded form like this, and this is a wet dupatta, so will it get if she kept it like this way in the sunlight, or another way is that she fold it like, if she open this like in this way, and then have this one on the rope, okay? So in which case do you think that the dupatta will dry faster?
So the second
Sir,
case.
second case.
Second
Second
case.
case.
Why? The reason is that when
Sir,
this
because
has
more
yeah,
surface area.
this is the small surface area, and this is the more surface area. So when the wind will blow, or the air will blow, it will take more particles of water along it. But here there is a less surface area, so the more air will not, the contact of air will be less in this case. As a result of which, we will simply say that the due to less surface area, the evaporation will be, okay, will be slower. Okay, because air plays a very important role in converting the or in the evaporation, or converting the liquids into gaseous state. Okay, so we will simply say that surface area plays a very important role. Surface area. Okay, so we can say here that more the surface area, more the surface area, more will be the rate of evaporation. Okay, done.
Yes, sir.
Second,
Yes, sir.
wind speed. If the wind speed is more, will the surface, will the evaporation will be faster or small? Slower.
Slower, sir.
Wind speed. Wind speed. Slower.
Sir, fast.
No. If the more number of particles per second is hitting in the when the wind speed is slow, the lesser number of particles will going to hit the cloth. Okay. But if wind is blowing faster, then the faster rate, it will, the more number of particle per second will comes in the contact with the clothes or the wet substance, okay, and it will take the more number of particles, so the fast it will be at faster rate. So we can say that evaporation is directly proportional. More the wind speed, more will be the rate of evaporation. Okay, more the wind speed, more the wind speed, more will be the rate of evaporation. Okay, next.
So humidity.
Yeah, humidity. Okay, humidity also. Temperature first. Let me temperature.
Yes, sir.
Temperature. Is temperature is directly proportional or is inversely proportional? Are you writing each of them?
Yes, sir.
Temperature.
Yes, sir.
If you increase the
Yes,
temperature,
sir.
will the rate of evaporation will be faster or small or slower?
So faster.
Sir,
Faster. You know
faster.
that clothes get dry more easily during the daytime than during the night time. Why? Because during the night hours, the temperature is less as compared to the daytime. So I'll simply say here the temperature is directly. The more the temperature, more will be rate of evaporation. Understood?
Yes, sir.
Next, if I'm saying if the temperature, now next is humidity. Tell me what is humidity?
So the amount of water vapor in there.
So the amount of water present in the
Yes. So if I talk about the humidity, okay. Humidity is the amount of water present per unit volume of air. Okay, that is called humidity. More the water present in the air, that is called more will be the humidity. The less water is present in the air, it will be, we'll say that humidity it will be less. Okay. Now, can you tell me that if the humidity is more, the rate of evaporation will be more or less?
so less.
Less. Why?
Less.
Why?
Uh, more water.
Tell me, other students, why not answering? Samia,
The less.
why it will be less?
Sir, it's because the drier the air, the higher the evaporation rate is. So if there are more water particles present in the air, it will be lower the evaporation.
Because already you know that water, when water get evaporated, where it is going to? Water can get evaporated, where it is going to go? It will be going in the air. Okay. Will it not vanish? It will not vanish. It will remain in the air. The water will is converted into gaseous state and it will remain in the air. But if the air is already, air has some water holding capacity, na, that it this particular amount of 1 liter, one volume, 1 centimeter cube or one liter air can hold this amount of water. If the already that amount of water is already present in the air because of humidity, the air already have so much amount of water in it. So the how this water particle, if there is already, for example, if you are going in a bus and if this bus is already full, there is no vacant seat, then how, where you will get, you will so we'll simply say that, for example, if the two buses are coming, bus A has is okay, bus A has a lot of empty space and bus B has no empty space or no vacant seat. So in which bus you will try to go? You will go in that one which is having more number of vacant seats. So simple is because same is for the humidity also, because all if the water content is already present, if the water content is already present, if the air is already saturated with water, so the more water cannot be added to the air. So the rate of evaporation, because when the water get evaporated, it is going into the air. And if the air is already packed with water particles, so it will not give you the space. It will not give you the space to, so that the water particles can added, more water particles can be added. Okay, because everything has some saturation limit, that this amount of water can be added to the air. For example, if you start dissolving, sugar in the water, it does not mean that you can keep on adding and it will keep on dissolving. No, it does not mean. After some time, a saturation condition, when all the intermolecular space of the water get filled with the sugar, then no more sugar can be added to it. We cannot add more further sugar to it because it is already saturated. It has already that amount of sugar that it can hold. It is already that one present in it. So it cannot further add. So saturated means no more solute, no more gas, no more substance can be added. That is called saturated condition. So simply say that humidity is inversely proportional to rate of evaporation. More the humidity, less will be the rate of evaporation. So more the humidity, less will be the rate of evaporation. Evaporation. Please note it down.
Done, sir.
Other students?
Yes, sir.
Okay.
Yes, sir.
The question comes in examination that Why do we feel uncomfort? Why do we feel okay? Because first of all, we need to explain you that evaporation causes cooling effect. The next topic is evaporation causes cooling effect. Evaporation causes cooling effect. Cooling effect. Evaporation causes cooling effect. What does this mean? Evaporation causes cooling effect.
So,
Yes.
in the process of evaporation, a liquid turns into a gas, so it requires some energy which it obtains from its surroundings. That's why it acts as a cooling process.
Yeah, yeah, very good. For example, this is a surface, okay, on which the liquid is being poured. Got it? The liquid is being poured. Now this liquid is start converting into gaseous state. Gaseous state. Okay. Now you know that wind speed is also playing an important role. If the more speed, the wind energy is also being used. But if this substance is having some heat energy, whether it is 20 degree, 40 degree temperature, it's okay. But if this sheet or this is having, okay, some this particle, this temperature is suppose 40 degrees Celsius, this surface is having 40 degrees Celsius. So when this liquid is converted into gas, when this liquid is converted into gas, okay, then it will absorb some energy. It will absorb some energy. Okay, it will absorb some energy from the surface on which it is kept, on which the evaporation is done. And if the heat is being removed from a surface, then in turns it will get colder. It will get colder. For example, if I'm saying that if you are having an iron pan, okay, and it is heated, you are heating that iron pan, okay, and if you kept it into the water, then you will see that water will instantly get converted into steam, and then you can easily touch that pan. You are confident then you can touch this pan because this pan is now under the water and it is cooled. Why it is cooled? Because the heat energy of that pan is being utilized by the water, which get converted into, because that pan's heat energy is being help the water, liquid water, to convert into gas, and this heat is absorbed from the surface or from which on which water is. If the water you are adding on the pan, so it will take the heat from the pan, and then in turns, if the heat from the pan is being removed, then the pan will become cool cooler. Okay, so we'll say that evaporation causes cooling effect. Why do evaporation causes cooling effect? Because during evaporation, the heat from the surface of the during the evaporation, the heat energy from the particles of water, or from the heat energy of the particle of the water, let you write it, that during evaporation, the heat is absorbed from the surface of the surface of the substance, okay, which help in converting the liquid into the gaseous state, and in turns it cools the surface. Okay, so we'll simply say here that why do evaporation causes cooling effect? Why do evaporation causes cooling effect? Causes cooling effect. So we'll simply say here that during evaporation, the water particle absorb heat energy from the surface of contact and and get converted into steam and get converted into vapor, bracket liquid, sorry gas. During evaporation, water liquid particles absorb heat energy from the surface of contact and get converted into vapor, which is gas. Okay, and thus in turns cool the surface. Okay, you done? You done this one? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Next. Now the question comes, why do we feel uncomfort? Why do we feel uncomfort during humid day? Is anybody in the class can tell me this answer? Why do we feel uncomfort during humid day?
Yes, sir.
Yes, tell me.
So humidity is uncomfortable because it holds the moisture to our body, which does not allow our body to cool itself. The sweat produced in our body also cannot evaporate easily since the water vapor is present.
The water vapor is present. Why do we feel uncomfort during the humid day? Yeah. Any other answer? Any other students? Saad?
Sir, it holds
No,
moisture
sir.
in our body and it does not allow us to cool.
Yeah. Simple. Because the rate of evaporation becomes slower. And you know that there are numerous pores on our body from which the water comes out in the form of sweat. And that water or that sweat get evaporated and in turns it cools our body. In turns, it cools our body. Okay. So we will say here
Okay,
that
sir.
why do we feel uncomfort on humid day? So you have to write the answer. On humid day, the rate of evaporation becomes slower. As a result, the sweat coming coming out from our body on humid day, the rate of evaporation becomes slower. As a result, the sweat coming out from our body do not evaporate. And and prohibit or this slowers evaporate slowly, coming out of our body evaporate slowly. As a result, cooling becomes slower. Okay, note it down. When you're done, please let me know.
Sir, done.
Sir, done.
As a result, दो बार है. 2 times you have written as a result, so you have to do a correction. And thus, cooling of our body becomes slower. Okay. The next question comes in examination that why do why do the water get cooler or water get cold or cooler during the summer season, okay, when it is kept in the earthen pots? Why do water kept in earthen pots, why do water kept in the earthen pot become don't write cooler during summer? Tell me.
So the water kept inside the pot evaporates and it takes the latent heat required for vaporization.
Okay, and in terms,
Water.
cool the surface, which further cool the water kept in it. Okay, so there's an earthen pot, and in earthen pot we have micro pores or minute pores from which the water comes out. Okay, keep on coming. So they are the micro pores here, and which from which the water keep on coming. Okay, and that slowly get evaporated, which in turn cool the surface by absorbing the heat of the water, sorry, of the earthen pot, and result in cooling the water kept inside it. So note it down. Note it down. So note it down. Water kept in the earthen pot on coming out of the earthen pot by the minute pores. Water kept in the earthen pot surface. This water get evaporate and cools. Which in turns decided. It's noted down. And when you're done, let me know. Hello Rita, how are you? Am I audible?
Hello, sir. Yes, sir, you're audible.
Okay, just a minute. Let the students finish this one.
Yes, sir.